Hey guys, today we're going to be talking about energy. So the first thing we need to talk about when we talk about energy is what is the definition of energy? Now, energy by its nature is going to be the capacity to do work. Now, work is something we're going to discuss here in a little bit, but by its nature, energy is something that can't be created nor destroyed. It kind of just exists, but it exists in a lot of different forms. And we're going to go through a lot of the different forms of energy. This unit, though, we're going to focus specifically on two major types of energy. The energy of heat and chemical energy. These can be broken down into those two major points throughout the unit, and we're going to really refer back to these frequently. Fundamentally, there are only two categories of energy that we're going to discuss here in this unit: potential energy and kinetic energy. So we can use an example of a ball sitting on top of a hill to kind of demonstrate these two types of energies. Now, obviously, this is going to be slightly different than the energies we're going to be discussing, but the premise is the same. Potential energy, if you want to think about it in this way, is when you have the potential to do work. So a ball at the top of the hill has high potential energy because it has the potential to roll down the hill. As the ball rolls down the hill, that potential energy is converted into kinetic energy. And kinetic energy in this case is the energy of movement, the moving ball rolling down the hill. As the ball rolls down the hill, it loses potential energy. As it gets closer and closer and closer to the bottom of the hill, the kinetic energy is increasing and the potential energy is decreasing. This is a conversion from one type of energy to the next. Once the ball gets down to the bottom of the hill and the ball stops, now all of a sudden it has lower potential energy than it started with. So what we have here is a situation where potential energy has been converted into kinetic energy, and kinetic energy is going to cause an overall reduction in the potential energy that the ball has. Now, the ball at the top of the hill is relatively unstable. It could roll down the hill. Similarly, if we see an object with high potential energy in chemistry, we can think of it as less stable. The ball at the bottom of the hill, however, is more stable. So if we see an object in chemistry which has low potential energy, we can think of it as being more stable. So let's talk kinetic energy. We're going to focus on the concepts of kinetic energy as they pertain to chemistry today. Kinetic energy, again, is the energy of movement, and a lot of things can be moving. So thermal energy, which is heat, refers directly to kinetic energy. In fact, temperature is simply a measure of average kinetic energy of molecules. In addition, we can have rotational, translational, we can have vibrational. These are all different types of kinetic energy of molecules. Other things that are types of kinetic energy include light energy and electrical energy. Now, we're going to use this equation frequently in this unit and in future units, and that's the kinetic energy is equal to 1/2 mass times velocity squared. What this is saying is that the mass of an object and the speed at which it moves is going to be directly related to the kinetic energy of that object. Now, the cool thing about this is that temperature is a measure of average kinetic energy. So in other words, we can look at the temperature of an object and know that if we increase the temperature, we have also increased the velocity by which those molecules are moving. And again, that movement of a gas can be translational, so it can move across the room, or it can be vibrational if you're in a solid. So if you're a solid object and you're increasing the temperature, those molecules are going to vibrate more frequently, more readily. And so what you're going to see is different types of kinetic energy in different contexts. So that was kinetic energy. Now let's talk potential energy for a minute. Potential energy is, again, energy where it has the potential to do work. Now that's kind of weird, and in terms of chemistry, we're going to discuss this as it pertains to the chemical composition of molecules or of substances, but it's a little easier to think about in the physical sense. A ball at the top of the hill has high potential energy, and a ball at the bottom of the hill has low potential energy. Now this relates directly to chemistry because of stability. Now, stability is something we haven't really talked about yet in this unit or in this course, but the idea is something that's stable is hard to break apart. Something that's unstable is pretty easy to break apart. So the more stable a chemical is, the lower the potential energy of that chemical, the harder it is to break that chemical into different parts. Well, this represents a reaction. So in other words, a more stable chemical might be harder to react than a less stable chemical. This is going to play a direct role as we go through this unit talking about different types of reactions and their energies. The most common type of potential energy that we're going to be referring to in this unit and in this course overall is the electrostatic potential energy, based on Coulomb's law. Now, we've already talked about Coulomb's law, and Coulomb's law, if you remember, has to do with both the charge and the distance of different particles. The more stable something is, the greater that force of attraction is going to be. So a strong electrostatic force of attraction, so strong Coulombic force of attraction, is going to represent a more stable thing versus a less stable thing with a lower Coulombic force of attraction. Another thing we're going to be doing in this unit is discussing a new unit. This new unit is the joule. Joule is a unit of energy. And 1 joule is a kilogram meter squared per second. Now, you don't need to know the breakdown of the joule into its respective parts. That's going to be more in physics. But in this case, you need to understand that a joule is a unit of energy. So we're going to see the unit joule and kilojoule very frequently in this unit. So get used to it now. So just out of curiosity, if I'm going to show you a bike rolling down a hill, I want you to tell me what type or types of energy does that bike have. So think right now about how many different types of energy that bike might have. All right, so now you've had a second to think about that. Let's think of a few. Well, first of all, the bike has, obviously, kinetic energy. It's rolling down the hill. Simultaneously, it has some level of potential energy because as the bike is still up the hill slightly, there's still this capacity for it to continue moving down faster. It continues to accelerate down the hill further. So what we see here is we have both kinetic energy and potential energy. You can also think of this as heat energy, all right? Because now all of a sudden as you're riding a bike, some energy of heat is being transmitted from you into the bike, from the wind into the bike, from the bike into the ground, right? So there are all these different types of energy that are all working together. There's also sound energy. You can hear a bike going down a hill. Right? It's not silent. Sound energy is a type of energy. So some of that kinetic energy is being transferred into the air around it, creating pressure waves that make sound. So this bike has so many different types of energies. Similarly in chemistry, the number of energies that exist, we are going to be kind of narrowing it down from what really happens. Right? We're going to focus almost entirely on chemical potential energy and on kinetic energy. Let's do another quick example. You see this boy with a bow and arrow. He's pulled back the arrow all the way back. So what kind of energy now exists within this bow and arrow? Well, he's pulled the bow back. So in theory, the bow has stopped moving. There's no movement here. So all of this energy that exists is stored. So right now, when you think about it, should only be potential energy. Now, as you can see, it can very quickly be converted into kinetic energy. If he now shoots the bow, all of a sudden, arrow flies off. That is kinetic energy. Additionally, you know there's a sound associated with a bow and arrow being shot. It goes sprung, and what that is a vibrational kinetic energy of sound. Again, pressure waves being created by the vibration of the string of the bow and arrow set. The string vibrates. That vibrates the air around it. That vibration gets transferred to your ears, and eventually it processes into electrical energy, which gets sent to your brain and is processed as sound. All these different types of energies that are held within this one setup. But again, you're going to need to understand before versus during versus after. So before the boy has shot the arrow, it's only potential energy. Now let's do a harder one. Let's think about fire. What kind of energy does fire have? So think about this for a second. Think about what is fire made of? What is fire? So give this a second, and if you need to pause the video and actually Google it, you can do that. Right? I want you to think about what is fire and what kind of energies are contained or emitted, as it were, within the fire. Now, fire is, if you remember, a combustion reaction. A combustion reaction is a chemical reaction. That means there's chemical energy of this reaction. But you can see with fire, you feel the heat. Heat comes off of fire. If not, then we wouldn't be using it the way we do. So energy, thermal energy, that's kinetic energy. The molecules are being emitted. Additionally, you can see the fire. That's light energy. Light energy is being emitted from a fire. Additionally, you can hear a fire. You hear the crackling sounds coming out of a fire. That's going to be, again, it's going to be a transfer into auditory energy or sound energy, right? All of these different types of energies that are stemming from a single chemical reaction. So in other words, now we can see a chemical reaction is capable of converting energy from one form into potentially many. Again, in this unit, we're focused almost entirely on chemical energy, which we will refer to in the future as enthalpy, and we're going to define that shortly, and kinetic energy, which again we're going to refer to often as temperature. So remember, different types of energies can be converted from one form into another. We have two major categories of energies, potential energy and kinetic energy. And in this unit, we're connecting these pieces together. And we're doing it all in the context of chemical reactions, phase changes, and other forms of energy changes that we are going to be looking into as we go through this unit. So that wraps up today's video. Let's do a quick recap. Today we focused on introducing the new unit. We talked about the two major categories of energy, kinetic energy and potential energy. Remember, in this unit, we're going to oftentimes refer to kinetic energy with the temperature, and potential energy we're going to refer to in terms of stability of the chemical compounds themselves. A lot of times we're going to be talking about the conversion of energy from one form into the other, or even the transfer of energy in the same form from one object to another. Make sure that when you're using this new unit, joule, you're always aware of the context, right? Joule is a unit of energy, and that can be used in a lot of different formats, and we're going to be using a few of them in this unit today. The last thing to keep in mind, as we looked at the chemical reaction of fire, the combustion, there was an energy change, right? We feel the heat. There's energy transferred out of the fire. That's something to keep in mind as we look at chemical reactions throughout this unit. There can be an energy conversion or an energy transfer in both ways. I'd like to thank Katie Dumais and Audrey Roberts for writing, filming, and editing this video. I'd like to thank you guys for watching. I'll see you in the next one.